Let us start the introduction part of sensors and transducers with the basic block diagram of basic instrumentation system. In this block diagram, we have the blocks. First block, that is a transducer. Then comes a signal conditioning, data transmission element, data presentation element, and then printer, display, and the controller. So first, the physical quantity is given to the transducer, where the transducer will convert this physical quantity into the electrical quantity. So once this electrical quantity is given to the signal conditioning, here what happens is the signal is improved by amplification, modulation, filtering, and analog and digital conversion. So here the signal is amplified to the required amount, and any modulation is also performed, and filtering, and then the analog to digital conversion is performed. Then this signal is given to the data transmission element, where it provides a means to transfer information or data from one point to another. Example, the means used are maybe the electric cables, radio links. Then comes the data presentation element. Here the data is transmitted and the data transmitted through the data transmission element will perform the amplification, attenuation, demodulation, and analog to digital conversion. And then the signal, after improvising, the output signal will be displayed or printed and given to the controller. This is the main idea, or this is the main block or the basic elements in the instrumentation system. Then coming for the main topic of the sensors and transducers, let us go with the main the module, that is our main topic of sensors and transducers. So when we come to the sensors and transducers, in the first module we are going to study about the typical definitions of transducers, advantages and disadvantages of transducers, and then the actuating mechanism, the different types of transducers, classification of transducers we are going to see in this module. So let us start with the definition of transducer. Transducer is a device that converts one form of energy to another form of energy. That means the signal or the measurand may be a non-electrical signal which will be converted to a electrical signal. The primary energy forms may be the mechanical energy, thermal energy, electromagnetic energy, optical energy, chemical energy, and etc. Therefore, the transducer is a device which is used for conversion from physical quantity to the electrical quantity. The transducer has two types of devices, that is sensors and actuators. Sensor is a device that detects a signal, but actuator is a device that generates a signal. Sensor systems may have primary transducer and a secondary transducer. The primary transducer converts the real world parameter into electrical signal, and the secondary transducer converts this electrical signal to analog or digital form. The two main functions of transducer are it detects or preserves the presence or magnitude and changes the physical quantity into electrical output. In general, we can tell that the transducer is a sensing device which converts non-electrical quantity to the electrical quantity. So an electrical transducer can also be defined as a sensing device which converts the physical, mechanical, optical quantity to the electrical quantity. The inverse transducer is defined as a device which converts an electrical quantity to a non-electrical quantity. So these are the definitions or the explanation for the transducer. Coming for the requirements of a transducer, that means a transducer should have some of the specifications to select a particular transducer for a particular application, in which first requirement is about the linearity. Linearity property is nothing but where the characteristics between the input and output are linear. Second requirement is ruggedness. So this is nothing but a property in which it can withstand the overload and protection measures. Then coming for the repeatability. Repeatability is nothing but whenever you are going to measure the output at different times, the output should be same. It should not change depending upon the environment. Then coming for the high stability and reliability. Stability is nothing but the output should be stable irrespective of the changes in the temperature, vibration, or the environmental conditions. Then next is the dynamic response. It should give the response should be very fast. That is the dynamic response. Then it should have the convenient instrumentation of measuring the high output, high signal to noise ratio, and a measurement after the amplification. So these are some of the basic requirements of a transducer. Then coming for the classification of transducers. Transducers are classified based on three main criteria. One is application, another is nature of output signal, and the third is based on the principle involved for conversion. So first, based on the application, we have two types of transducers, that is active transducers and passive transducers. Based on the nature of output signal, you have analog and digital transducers. Based on the electrical principle involved, we have variable resistance, variable inductance, variable capacitance, and variable generating type, voltage generating type, voltage divider type. So this is for today's class, and further from tomorrow we will see the different types of transducers.